Hello friends, I am Dr. Mahantesh Swami. This is my second video lecture on the course of numerical analysis for BSc 5th semester students of Gulbarga University. In this video, I am going to explain about the concept of errors. So first of all, let us recall what are the things we have studied in the previous session. In the previous session, we have discussed about the exact number, what is meant by an exact number, what is meant by an approximate number, and what is the rounding off process that we have discussed in a detailed manner. And we have also seen what are the important steps involved in rounding off a given number. In the present session, we will be able to understand the following concepts. Error, we shall discuss what is meant by an error, and we shall see three important types of errors: absolute error, relative error, and the percentage error. So first of all, let us define what is meant by an error. Error is defined in this way: if x dash is the approximate value of an exact number x. So here we have to understand what is meant by an exact number and what is an approximate value of an exact number. So exact number is the given value of a given number. That is, if x is the given number, which is exact value, and x dash is its approximate value. You have seen by rounding off the given number x, the value which we obtain is called as an approximate value. Or we can approximate the given value in any other different way and can take the approximation of that as x dash. So here we have to understand x is the exact value and x dash is its approximation. If we consider the numerical difference of x and x dash, that is, if we consider x minus x dash, then that value is called as error. So error is nothing but the difference between exact and its approximate value, and it is denoted by delta x. So the notation for error is delta x. Now let us discuss what is meant by the absolute error. If we consider absolute of the error, we have seen that x minus x dash, that is the numerical difference of given number x and its approximate value x dash, is called as error. If we take the absolute of that, then we will get the absolute error. So this is the definition of absolute error. Now what is meant by the relative error? Let us see. Relative error is absolute error divided by the absolute value of the given number x. We have seen that absolute error is absolute of x minus x dash. So absolute of the given number minus its approximate value, that we have seen it as absolute error. If we take the ratio of absolute error and the absolute of the given number x, then that gives us the relative error. So this is how one can define the relative error. Now we shall see what is meant by the percentage error. Relative error into 100. So we are defining the percentage error. So how to define the percentage error? Percentage error is 100 times of the relative error. We have to first find out what is meant by the relative error by using this definition, and we have to multiply 100 to that answer. That gives us the percentage error. So these are the definitions of error and three important types of errors. Now let us consider one numerical example on these definitions. So let us have the first problem. Here in the given example, we have to understand 1 by 3 is the exact number. So 1 by 3 is the given value. We know that its numerical value is 0.333333 like that. non-terminating, infinite decimal digits will be there, and that has been approximated by retaining only 3 digits after the decimal point. So this is the approximate value of the given number 1 by 3. So here x is 1 by 3 and x dash is 0.333. This is x dash, this is x dash, and this is x. Now we have to find out here what is meant by the absolute error, what is meant by the relative error, and what is the percentage error. So let us first denote these two values with their symbols. I have already told you this 1 by 3 stands for x, so we have to take it as x, and the approximate value is always denoted as x dash, so we have taken x and x dash like this. Now the definition of absolute error we have in our hand. Definition of absolute error is absolute of x minus x dash. So we are considering absolute of x value is 1 by 3 minus sign as it is, and x dash is the approximate value given, that is 0.333. and if we simplify this using our calculator, or we can simplify it in a very simple way. Here I will tell you how I have simplified this. 0.333 stands for, we can write this 0.333 as 333 divided by 1000. This all of us know right from our primary school. For this one we are for this point we are writing 1, and after that there are 3 digits after the decimal point, so we are writing 3 zeros. At the denominator we should write 1000 for that, and in the numerator we can write the number without any decimal point, so the number will be 0333, that is 333 divided by 1000. This is the value of x dash after simplification, and here 1 by 3 as it is. Now it is simplification process, taking the LCM and simplification, that gives us 3 into 1000, the LCM will be 3000, and after simplifying this the answer is going to be 1 divided by 3000. So this is the value of obtained after simplification. This we can do like this, or directly we can use our scientific calculator and we can write the value of this as 1 divided by 3000. So this is how we have computed the absolute error. Now the value of 1 divided by 3000 is, after simplification we can write it in a more systematic way as 0.00033. So this is the final answer for the absolute error. And now let us see how to get the relative error. So relative error is the definition we have already seen. It is absolute error divided by the absolute value of x. So that we have seen. Absolute error we got in the previous step as 0.00033, and the value x which is given as positive, absolute of that is again positive, that is 1 by 3, and if we simplify this the answer is going to be 0.00099. So this is how we have computed the relative error of a given number. Now the percentage error, the final stage, percentage error is very simple. It is relative error multiplied by 100. So that stands for the percentage error. So we have computed relative error as 0.00099. If we multiply 100 to that, the final answer is 0.0099. So this is the percentage error of a given number. So this is how we can solve the given numerical example using the simple formulae, the definitions which we have discussed in the beginning. So with this I would like to conclude to the discussion. There are simple questions. You can answer to these simple questions later on. Please write your answers in the comment box. So see, this is the first question. This is the second question, this is the third question, and this is the fourth question, and this is the fifth question. So please try to rewind the video, watch it and try to answer these questions. And once again, you try to have the reference of this book written by me, and it is available as UG Mathematics 5 numerical analysis. So with this, let me conclude. Thank you.